have merge with machine and live forever on Earth or some other place in space. And I have to say again, it's because they're scared of dying.
Just as long as a lean, healthy mouse, which means that they didn't get heart disease, cancer, even osteoporosis.
A lean, healthy rat. That's the moral of the story here.
And they lived 30% longer.
Can you do this in humans?
We have the same exact gene. And we think that resveratrol could have similar benefits in people.
Realizing the blockbuster potential for his new pill, Sinclair teamed up with biotech entrepreneur Chris Westphal, together raising more than $100 million for further research.
And we think that we can increase healthy lifespan. So if you're in your 80s, you'll be behaving as if you were in your 50s.
In the first human trial, a form of resveratrol successfully treated type 2 diabetes, one of the major diseases of aging.
If everything goes very well, we will seek regulatory approval from the FDA in the next 5 years.
I think a lot of people will say you're raising expectations. This can't possibly happen.
My answer to that is, I agree, but it's true. What else can I say? Aging is really a set of diseases, and if we slow them down and cure them, people will live longer, healthier lives.
And you're talking especially now about diabetes and Alzheimer's?
So the major killers of Western society are exactly the diseases that should be able to be treated with the drugs we're developing.
Well, you know what, Doctor?
Cheers.
It's the future.
Okay, but I mean, really, disease is just the tip of the spear, because even if you're able to stop the disease, then you have to be able to regrow organs, which is what they're getting ready to get into here in just a little bit. Got just a couple of minutes left in the show here. I'm going to go ahead and skip ahead just a bit. Okay, here we go. This is very interesting stuff.
A cell's age can be measured by those little yellow dots called telomeres. What is a telomere?
Telomeres are the body's aging clock. The genetic makeup in our body consists basically of strands of DNA, sort of like this shoestring. And at the end of these strands of DNA, there are these little caps. And these caps are the telomeres. And every time your cell divides, that gets shorter and shorter. And then when it's gone, or a certain shortness, it dies. With embryonic stem cells and cloning, we're able to create new, healthy cells that have fully restored telomeres, just like a brand new shoelace.
These cloned cows could live to be the oldest on the planet. The same effect applied in humans could extend our lives to more than 150 years. Dr. Lanza's next challenge was to learn how to regenerate damaged body parts. He started by observing how the body works to repair itself.
We're not as clever as nature. It actually turns out that when your tissue is damaged, it sends out signals that say, help, help. These cells are smart, and they know exactly where to go to fix the tissue, and they won't go anywhere else.
Then Lanza tried it, injecting stem cells into injured animals.
What we found, literally, within 24 to 48 hours, they went right to the site of the damage.
You just put them in the body, and they say, I'm going to go to the eye, I'm going to go to the heart, I'm going to go to the liver.
That's it, exactly. These are the body's master cells. They're actually immortal. They grow forever, and we can turn them into virtually every cell in your body.
And Dr. Lanza has even grown the fluid of life in his laboratory, human blood. This is blood made from stem cells.
Yes, this is a human red blood cells that we generated from embryonic stem cells.
He removes a single cell without harming the human embryo, and he turns it into stem cells.
And the beautiful thing about that is that it's universal. It'll match everybody, so you won't have to worry about tissue typing.
Tissue engineering researchers liken the process to restoring a classic car. A part wears out, just replace it.
And someday, if you get in an auto accident, we'll just take a skin cell and grow you up a new kidney.
Muscles, heart valves, arteries, all growing in the lab. So cells could, in the future, replace almost any part of the body.
Absolutely. We're doing this today. I know it sounds crazy and it sounds like science fiction, but we're already learning how to fix the body.
Human bladders grown in the lab have already been successfully implanted into 7 patients.
Now we'll feed it.
Dr. Doris Taylor, director of the University of Minnesota's Center for Cardiovascular Repair, also sees huge potential for stem cells in treating heart disease. The problem is a lack of healthy hearts for transplantation.
We need a heart. Why not go for the gusto and see if we can build one? What do you need to build a heart? You need cells. Well, we got cells. Stem cells are us.
Dr. Taylor went to work harvesting heart stem cells from rats.
Wouldn't it be cool if we could take what nature's given us, which is a heart, beautiful organ, remove all the cells and put new cells back? And from that, the idea was born.
After injecting the heart stem cells in an empty heart framework, the cells knew what to do. Just add nutrients and a pacemaker. Within days, they had grown into a living, beating heart.
The coolest thing is we put the electrodes on, we teach the heart what to do, we can turn them off, and it keeps beating. It's phenomenal. We've opened a door that's going to provide another tool for organ transplantation in the future.